Alright, so I have used a different machine. We're now on an MSX2, and the reason for that is so we can have a disk drive, which we will add. Well, one that works at least. It didn't work with my original machine, which was the one I was using in 1985. So I picked a different one, and that seems to work. So now at least we can figure out the construction stuff a bit more. And after that, we'll continue doing the algorithm for the level saving. So let's go to construction mode. And I think it was here. Yeah, I think it was around here, or maybe a bit down. Yeah. So now I have the option to, well, I have to add a disk drive. I'm not sure if I have to reset now. Let's give it a disk. So now I at least can load the files. Well, I might have to reset though, because I did add that thing. Yeah, let's reset. Because I added the disk drive like just on the machine while it was running. So we have a disconnected or inserted at least. Right, so now I can switch devices here, which I couldn't do. It already gives us our option here that we didn't know. Yeah, and then we have the file listing, and that contains, or I've already tested with a couple puzzles. But yeah, let's start adding some variables here. So our device check is, or device chooser is D931. Okay, and that is indeed the file name, but we will see. So construction tape or disk, that's D931. And the values are 1 is disk and 0 is tape. Okay. Okay. The file name also is what we suspect it to be here, right? That is actually the file name indeed. I've already checked that. So there's these values here. If I do, because if I now select a disk, so if I had a tape, which was the only option before, I couldn't. Well, I could. Yeah, so I forgot to actually type letters there when the save and load is selected. But yeah, so we can enter a file name, and that does indeed appear here. So the last one, this 3B, is related, but yeah, that wasn't part of the file name. So these are for sure the file name. And I don't know why this file name is here as well. This might be something that's on disk though. So if we go look at the disk, I mean, I think I had more than one file on there. So let's pick up the, yeah, so we have, well, test1 is an empty file, right? So I didn't, there's nothing on there. But yeah, test2 exists.pzl. So it might actually list the contents here if you go to the files list, perhaps. But yeah, let's remove the probably here, because that's definitely the case. Okay. Okay. All right, so we have the file name. Over here. So we'll have to reload without looking at the files, because that might influence it as well. I mean, this memory doesn't go away though, like that's a bit annoying, unless it maybe now goes away. No, so that stays, that's a bit unfortunate. Maybe if we go in construction mode. Yeah, no, so these values, they do remain even if you reset the machine. I mean, I can really turn the power off, that should do it. Yeah, that does it. And then, let's see. What is present now? Okay, now we're clean. Okay. I assume this is because I did the files routine. Right. Right, so I mean I can write here and that's just entered there. So the other one doesn't show up from the moment until the moment I go to files, I think. Yeah. So it did load and it adds it here. So maybe there's not lots of space because this one is the current round. So we only have like place for a couple, I think. I don't know how that works, if there's a limit or, but this is this contents maybe amount of files and then file name 1, the amount of spots, and then maybe file 2 and 3, I don't know. But there's definitely limited space, so depending on how many puzzles you have on your drive, I don't know how it's going to do that. We can try that later. So yeah, we've added those. And then the interesting part is if we do save, so now the first 5 rounds are loaded, right? So I have 1, 2, 3, 4, 5 levels loaded, which are the default levels in the game. And if I do save those, we can take a look at the first 5. Wait, I have to do a file name. So first 5. If I save that, that's completely. Oh, it's doing it again. So it crashes, right? I've had this problem before where it just crashes and everything gets reset for some reason. I don't know why. That's why I had to use this machine. So now it's completely broken now. But let's go look in the disk, see if it saved it. Yeah, no, see, it's a 0-byte file. So I did manage to do it once before, but yeah, this is very weird. I don't know why it crashes, and it like overwrites everything with F. Wait, are we in? Oh no, we're back in the VG8020. I don't know why I did that. I need to be in the MSX. I picked this one. Right, so is this, wait. No, we're still on a, okay, I need to replace. Okay, so now we're in MSX2, and then it doesn't do the crash for some reason. Yeah, so this has a built-in disk drive. Yeah, that's why I was confused. We do have to disable the other one though. Is that active? Oh, I'm not sure. I guess not. Because now it's the built-in drive. So this machine, this NMS machine, has a built-in disk drive, whereas my first one, the VG8020, which I had in the 80s, that didn't, because I never had a disk drive, right? But yeah, now if we apply this disk and we load the ROM, the plain Eggerland ROM, now it won't crash, or shouldn't at least. So yeah, I don't know why that's the case. It looks a bit different as well. Where are we? Here. Yeah, it's much darker and stuff. That's interesting too. So we're going to take the first 5. So first 5, that's as our file name. I'm going to save that, right? And this doesn't crash. So it did stuff with the disk interface, I guess, some timers or whatever. And now it is saved, so it's not crashed now. So let's look at the file now. It's going to be the same file as I already had, but fine. Right, so first 5, 216 bytes. So now we can take a look inside this file. No, I have to export it to disk here. So let's copy this file, first 5, and then let's take the hex editor and take a look at that. That's in Git. Okay, so I'm opening first 5. These are the 216 bytes. And we'll see now where this level data is stored, right? So the assumption is that it is the exact same data as is in the ROM, because it's level 1 to 5, so like it has to be the exact same, right? And to do that, we have to go look at where the level is stored, the first 5 levels. And that was in, so we have the earliest pointer or array of data here is in 6D56, and that's the pointers to the level data. So these are pointers, that's a list of pointers, and it runs until here, right? So we have pointers for the bonus level as well. We have 5 per section, so 5 per pointer, so we need 20 pointers, and then the 5 extra levels are here somewhere too, I think. But yeah, we have 1632. Wait, no, there's more pointers than necessary here. Maybe there's some extra data at the end. But yeah, D5, F8 is our first set of 5 levels. D5, F8. I have to swap those around because of endianness. Okay, so this is indeed round 1 map data power up 1, 2, 3. 1, 2, 3, and a Lolo starting index for the first level is position 0, 0, X0, Y0. And then we have the data until here, right, for the first level. Of course, for the first 5 levels, that's down here, I think. But if we go look, we have 4 zeros, 85, A5. That's like literally the same thing we see here, right, here. So we have a header. I don't know if that changes, but we have a couple bytes header, probably to identify that this is indeed like Eggerland 1 levels. But then, yeah, we have our 4 zeros, which is power up 1, 2, 3, and then we have Lolo starting index, 85, A5. It's literally the same data. It ends with 28OF. That's indeed these guys here. From here to here are our first levels. So obviously, they're dumping the same data onto disk, right? And that is what we were investigating last time, how these are encoded, right? Because we did figure out the Lolo starting index and the exit index for the door, which was 8 horizontal, 5 vertical. So 1, 2, 3, well, it's 0 based. 0, 1, 2, 3, 4, 5, 6, 7, 8. And then 0, 1, 2, 3, 4, 5. But then the actual data, as in these walls and these hard framers, have to be encoded in the data as well, of course. So that's what we were figuring out. I'm going to leave this open. So at least now we know how to save and load files, right? So we have our variable for this choice. We found a file name, and that's all we can do here. Like there's not much more. Also, the disk contents are something we can figure out, but that's not super important, right? It like just loads the files. Right. So then we can take a look again at the little algorithm. And of course, I don't remember where exactly that was, but we can go put a breakpoint or a watch point on this one, and we will immediately see. Of course, I'm going to go back to my original machine, though. I don't need this MSX2. I do prefer my original machine from the 80s. And that should do fine as well. Let's load the ROM, let's load the cartridge. Okay, yeah, so we have to be playing here, and I'm going to put a watch point on a read memory watch point on this starting thing, and we will break now when we load the level, right? So we saw this, yeah. So we're loading the HL is pointing to the start here. I'm gonna make this a bit smaller because we just have to look at this data here, right? So we're looking at these bytes here, 88 until A8 here. That's the definition of the first level. So pointer should be to D5FE, that's correct. HL is pointing to that because we picked up that value and put that in the accumulator. Then we were ending with 7, adding 1, right? And that becomes C actually, that's saved in C, right? So we got the 3 bottom bits and we added 1. And then we get the top 5 bits and we put that in a separate variable. And these values were being saved in C000, I think it was. So let's take a look. Yeah, DE already has C000 in it, probably from higher up here somewhere. But that's not too important to figure out how the levels are loaded. Yeah, so let's open a different window with C000. Okay, I don't want you to be in the same window though. I mean, I can't drag the, oh yeah, you have to drag this out. Yes, I do. Okay, so don't crash. Okay. So this goes in C000, and that is, so the sprite pattern table, right? Which we have to copy to VRAM. Wait, I can turn this off. And I can make the window smaller then. Okay. So because we're gonna write in this thing here, right? So we have the bottom 3 bits in the accumulator now, which for the first level is 0. Okay, because 88 is what we're looking at, right? The first byte here, 88. That's just 1000 1000. So there's no 3 bytes at the bottom, or set at least. Okay, so we load that into C and we add 1. That's this +1 here. And then we load again the 88 into the accumulator and AND it with F8. So now we're taking the top 5 bits. We're doing nothing else with that. We are putting that value into the sprite pattern table though. That is this one here. We're saving variable 2 into the sprite pattern table, which we are doing here, right? So this 6 becomes 88, right? So top 5 bits, that becomes 88. Not sure exactly what that means, but fine. Okay, we're pushing something on the stack, that's fine, because we're gonna make an offset, I think, right? So we're loading B is 11, right? We're exchanging HL and DE, that's fine. Because we have to add stuff to specific, we have to do that in specific registers. So we're adding, we're incrementing our pointer into this pattern table with 11. Right, that's what we're doing here. I is the index into the pattern table and we're adding 11. Right, that becomes COOP. So we're not sequentially adding information here, we're actually adding it like here in this one for the next run, for the next byte here, which is also a bit strange, but sure. And then we're going back as it was. And we're loading the value of D912. That's unknown. And I don't know, because we set this here, right? So we'll, oh yeah, no, that's our counter. Okay, so yeah, that's our counter. So we had 2 counters. We did something for every byte. So we have to keep track of the amount of bytes, where we are. But we also had an 11 counter that was set up here. That's our 11. We load that into D912. So now we're loading that and subtracting 1. And then we can jump out if we reached 11. Not sure what will happen after 11 thing. Oh, well, I mean, it's clear, right? There's 11 horizontal blocks. So it has to do something special when we're at the end, probably reset some pointers. So we are incrementing the Y count, like go to the next row and continue on with processing the bytes. Yeah. Right, so we're that's not going to be taken because we're not at the end yet, right? And then we're saving that back into D912. So D912 is level loading the horizontal block index, I guess, or horizontal block counter. Loading horizontal block counter. Okay. So we're saving that. Let's put that in the memory here, right? That's our horizontal position. Okay. Then we have, okay, we decrement C. Yeah, so we have 25 in C. That's the amount of bytes, hexadecimal, between this guy, so the first one and the last one. And we're decrementing that, meaning it's just an iteration, a loop iteration. We're not indexing on this value, it's just a counter. So yeah, we did this byte. It's not 0 yet. So we're not jumping here. And we're increasing HL, meaning we're going to the next byte, right? The D5FF, increasing HL. And then we go back to our, so C, oh no, the B register is decremented, and then, oh no, wait, no, our C, yeah, wait, no, yeah, that's this check. This wasn't a loop counter. This is the loop counter is in B, which is 25, which will now be decremented with this decrement and jump if not 0. Yeah, so this decrement C, that was the, which one did we put in C? Oh yeah, this top bit, right? This top var 1, right? We decrement here, and that became 0 because we're doing +1, right? So there was nothing in there. We added 1, so it was 1 now. We're decrementing here, and then we're checking that one. So if this variable 1 is not 0, in other words, if the bottom 3 bits of these guys are set, which is the case in the next one, then we're going to do something, right? And also, if the counter is 0, then we do something as well. Well, no, this needs to be I though. Wait, no, the I was the index. Okay, yeah, that's 11. Oh yeah, no, our counter is also 11. Okay, sure. Is this index related? Let me check. Well, no, we're starting at 11 though. No, this is starting at 0. So yeah, this is our counter, is our, this should actually be like, oops, our horizontal, like this is the horizontal counter, right? Because I'm assuming it's going to go to 11, although it's counting back. So it's like, well, it's a counter. It's not an index, right? Okay, so we jump back up to A517. Oh, I forgot to add this one to the coloring. I have to do that still. Right, so we're back at the top. We're doing the exact same for every byte. So question is, what will happen if this variable does something, like if the bottom 3 bits are set, then we do something special, which is going to be the case in this one here. And of course, what happens if we end up at the end of the row and then we have to go to the next one? We have to do something there too. But yeah, looks like, so we're now pointing to this guy here, right? B or C or D or something. So 11 positions down. So not sure why that is the case, unless the orientation is saved from top to bottom and they have to map from top to bottom to left to right, perhaps, in this array. I'm not sure why that's the case. Okay, so let's take a look. So yeah, the next one is going to be 0f, and that has the bottom 3 bits set, right? So we're loading 0f in the accumulator, we're getting the 3 bottom bits, that becomes 7, because f is all ones, right? So we're dropping the top 1, which is the 8 bit. So we have 1, 2, and 4 left, that's 7, okay? And we're adding 1. Right, we're saving that in C and we're adding 1. C becomes 7, now becomes 8. Okay, and then we're loading the value of HL again. So that's again the OF into A, adding or getting the top 5 bits now, which becomes 8 because 0F, 0, the top 4 bits are unset, and then we just have 1. Oh no, well, if we take the top 5, we have 1 in the 8th position, so that becomes 8. So that's our variable 2, which we get to save in our current index. So 0 plus 11 is 11 now in the sprite pattern table, which is COOB. That's here the B. That becomes 8, right? Again, we're loading 11 into BC. Okay, we're again incrementing by 11, sure. Right. Getting the next address, which is CO16. And we're decrementing our horizontal block counter. We're not at 0 yet. Saving the block counter. And now, okay, so now we have 8 in C, right? That's from this one. So 0F, the bottom 3 bytes was 7, plus 1 is 8. That's what's in C now. Previously, that wasn't the case. Like, now we're going to do something else because we're going to take this jump. So we're going to remove 1 from C. I don't know why we added then, but sure. So we are in this do something now. So we're going to jump to A51F, that's above here, A51F. Oh, okay, that's interesting. So we're looping to the same thing here. Normally we would jump, so down here, if we are done here, we would jump to A517. So that's our regular return of the loop. But now we are jumping earlier. We are jumping to A51F, which is here. So what we are skipping is loading of the byte, getting the 3 bottom bits, and getting the top 5 bits. So what's interesting is we're not loading the next byte yet. There is still information left in this 0F for some reason. We haven't done anything with that yet. Remember, because last time with 8.8 it was 0 and we did not take this jump, right? So now let's see, we have 8 in the accumulator. So we're going to take this jump here. And where in the routine do we end up? We're loading the accumulator into DE. Okay. So now we are doing this. So we're not loading these guys. Oh, we're doing the same thing with the bottom 3 bytes. Okay. So we have the top 5. The top 5 get put into the VRAM thing. We increment its position by 11, right? And then if the bottom 3 bytes minus 1, so I'm not sure why this plus 1 is here then, if that is not 0, we're also putting that in the sprite table. Okay, so let's see. Oh, right, wait, so let's see. We're loading that into CO16, right? CO16 here. Yeah, that got 8. That's our remaining thing here, like that. Yeah, that's this guy. Okay, so we have to do plus 1 because we have to save plus 1. Okay, we have to save the 8. Okay, so we're putting that in the VRAM, or the sprite pattern table at least. We're incrementing again, sure. Okay, we've processed a block horizontally, so that was the actual block. So we're incrementing the block counter, that's fine, or decrementing, I mean. That it's not at the end of the row yet, that's fine. So we're getting 8 back in, no, 7 now. Wait, so it becomes 7 again, so we do take that again though. Oh, right, and we're decrementing, so now we're doing this for 6. So this is an amount of times we have to put this, like, I mean, it's going to put 7 now, 11 bytes further down, until that reaches 0. That's quite interesting. Why would we do that? I mean, it sucks that I don't know the exact data that's in here, though. Okay, so we're gonna jump again, right, to 851F. Meaning, so we put 8 in CO16. We're pointing now to CO21, this one, and I'm assuming that's going to get 7 in it. Let's see. Wait, we have no 8 again. Let's see what's in the accumulator. Yeah, that remains the bottom 3 bits plus 1, right? That remains in there. Okay. Okay, so we're adding 11 again to this index. That's fine. Now we're at 2C. And we are not at the end, so we're checking the end again. And again, now that becomes 5. So we're doing that 8 times. Okay, so if we look, we actually have, I mean, I don't have to put semicolons here, I guess. So this is a little function, I guess. Yeah, we're going to recursively call that. So, I mean, let's call it just process for a moment here. Right, so this one calls, well, let's give it a variable, process data, and it gets saved into things. So first thing we do is we call process data, var2 I mean, right? And then we will check if var1 is not 0. We do process with var1. I mean, it's going to be var1 minus minus or decrement var1. Before or after, I'm not sure yet, but let's see. I think that's what's happening, right? So if the horizontal counter is 0, then we do something, that's fine. Yeah, I think that's what's happening. So yeah, we do this with the top 5 bits first, and then the bottom 3 bits plus 1. And so if that's done, we loop this. So we have to do this until the bind count is reached, right? How did we figure that out again? This amount of bytes, was that saved somewhere? Yeah, how did it figure that out? So we have 25 at the start, right? Yeah, how did we figure that out? I'm gonna have to go back here. Wait, I have to figure that out first, because that bothers me. Okay, I'm going to restart this, and my breakpoint is still set, so we can go to, well, no, it's gonna remove the watch point if I load a save state. So let's just restart this. Yeah, so the 26 or the 25 hex bytes was determined perhaps before we read this memory here. Yeah, B already has 25 in it, so I guess that is counted a different way. So we're loading A into B, we're ending with 7F. Okay, so that happens here, right? We have to know what HL is pointing to here. That might be interesting to look at, because this determines the length of the level, which is variable. That's why it's interesting. If it was fixed, then it would simply be a hard-coded value. But here it is actually determined from something what HL is pointing to, and then ANDed with 7F, meaning same thing, we get the top 5 bytes, right? Would that be that 8 here? Some let's see. Yeah, let's break here. Oh, that happens all the time though. That's not good. So that's not the thing here then. Wait, am I too? Oh no. It's always loading these values. Okay, that's fine. Where's my keyboard? Did I close the keyboard? Yeah, so now I have a breakpoint a little bit higher up. Let's see. We should hit that first. Yes, we do. So HR is pointed to D5FD. I'm gonna okay. That points to the second byte. Oh no. Oh yeah, we do have that. I was confused. Okay, no. We do have the length. Okay, sure. Yeah, I forgot. I was confused about. So we have power-ups, we have Lolo starting index, we have the exitor index, and the length of the rest of the data, of course. Yeah, no, that's not a big deal. Okay, so we are in the first routine here. Okay. The first iteration, so we're back on 8.8. And then we look, right, so we initialize our horizontal counter to 11. That's done here. Yeah, right. So we start with 11 into the horizontal block counter, and we are writing the value of HL pointed to the first byte here, FE, yeah, into the, okay, and then we start our function. Okay. I is the index in C0 that starts at 0, of course. And then we do our processing. Okay. And we process this with the top 5 bits, right? So yeah, so that becomes 1. That's this guy. Then again, we're doing the top 5 bits, loading that into DE. Yeah, so and that gets saved. So that's immediately gets saved, which is the entire var2, right? Yeah, because that's what we're doing here. So yeah, this variable becomes data, gets written immediately in the index in the pattern table, and then we don't have anything in var1. So this is going to be skipped, and then we loop back, right? So actually we are doing this, except, yeah, I think the function starts here then. So load level data, and we have a length. And that length is decremented. Hi, Kimberly. We are picking up where we left off last time, which is loading or seeing how we can decompress the level data that is stored inside the ROM image of the cartridge. So it's a variable length encoding and a compression or whatever. And we're figuring out how the data is actually, the level data is stored inside the memory, because it's used not only in the ROM, but also on disk for when you save levels in construction mode. So that file format, or like that encoding, is interesting to figure out, because that's like the way they used back in the day to save levels, right? So that's what we're doing. And it is slightly complex, but I mean, should be fine. Wait. Oh, yeah. Oh, this unknown we're figuring out now. Okay. So load level data has a length. That length comes from this guy here, right? No. Oh, I'm missing here something too. That's not correct. So we have the power-ups, 3 bytes. Then we have Lolo start index, exitor index, and then byte data length, and then we have the data. Right. Yeah, no. This was wrong. So yeah. It's the level data that gets used. Wait, I'm correct, right? So we were looking at D5FE. Yeah, no. This one isn't interpreted in this way. It starts here. Okay. Yeah, and we then decrement the length. Okay. And then we do start over loading the bottom 3 bytes. So I wonder if it's always 8. Because this is like a counter, or like an iteration. How many times do we have to keep writing stuff 11 bytes in 11 byte sequences, or intervals in this sprite table, the sprite pattern table? And in the first case, it's 8, as in we have the 3 bottom bytes of 0f was 1 to 4, which is 7. We're adding 1 and we're writing that 7 times. But I'm guessing if it's lower, yeah, over here we're going to have something different. So 10 is 2 and 8, so we're having 2 in the bottom 3 bytes. So we'll see what we write here. But I think this is now correct. Let's loop. So yeah, we're subtracting 11. That's fine. Or no, we're indexing into C000. We're looking at our horizontal progression. Not the case. We're not at the end yet. We're saving that. So now, yeah, so this became, there was nothing in there. Like 88 has zeros in the bottom 3 bytes. So the bottom 3 bits are, the bottom 3 bits are 0. We're adding 1. So we have 1 into C now, but we're subtracting 1. All right. So we're not doing anything. Yeah, we're not jumping. We're not taking this call here. That's this line. Because at this point, so here we would have jumped. I mean, we're going to see this in the next iteration though, but we would have jumped, and in the accumulator is 88. And we would jump to 851F, which is here. And we are loading that into, okay, so let's look at the next iteration then. So we're incrementing our pointer. Now we are pointing to OF, the second byte in our level data. And we are starting the loop again. So we are, yeah, so D, J, and Z, that decrements the B register, which is the length. So we're decrementing that. And if it's 0, in other words, if we've processed all the bytes, we continue, but that's not the case for a long time. So we do jump. And then, yeah, so we do put, oh, no, we're loading the byte. We're loading OF into the accumulator, okay. Again, doing this thing here. And now that has become, so OF, that becomes 8 then, right? Yeah, we're incrementing C. So our little counter here for 1 is 8 now, coming from this OF, right? So we're going to either do something 7 or 8 times. We're going to copy a value that we are going to calculate now into the sprite pattern table. So we are loading, okay, so we're loading, and we are doing this guy tunen, I mean, I guess. So we're loading F8, or we're ending with F8 again, top 5 bits. Oh, and that becomes 8 then, okay. Because that's the value we're going to write into our pattern table here n times. So the first iteration writes it once, that is this one. Okay. This isn't correct. We need a separate counter here, because the value that's being written here, the parameter to this function is always going to be the same. That's 8. Yeah, we're using different registers here. That's why we're using C. C is a little counter and A is the value. It starts at 8. We're counting C down from 8 to 0. And then we keep inserting 8 into the sprite pattern table for n times. So yeah, this is incorrect in the sense that we have to have a sub counter, and that sub counter is for 1, which I'm assuming we can assign here, right? And then we are decrementing. Yeah, that makes sense. Yeah, because it's the same thing. So actually, if the sub counter isn't 0, we decrement it, but we process it still with var1, meaning our bottom 3 bits plus 1. Yes. I think that's what's happening. Because yeah, if we look now, the value that's going to be inserted in COOB, that should be 8, right? Yeah. So yeah, that's this instruction. So we're loading 8 in there. Okay, do it. Yeah, so that became 8, and then we increment our pointer to point to, what is it, 6 CO12 or something. So we're adding 11, right? So that's this little calculation. CO16 is the next one. Yeah, this one, and we're doing this 7 more times. Right. Okay, so that's fine. We're checking whether we are at the end. That's this check. That isn't the case. Right, and now C is our sub counter here is decremented, and then we jump. Okay, so this order is correct as well. And we are jumping with var1 in the accumulator, because that is what's going to matter now. So yes, we are taking the jump. Yeah, and we are loading the accumulator, which is var1 into, like that's this, right? So this calls process with var1, and we're saving that as data here. Yeah, so this is going to happen 8 times, I'm guessing. I'm pretty sure. Yeah, so we put 8 here, and then we repeat the routine, right? We go 11 farther. That's this one. We check whether we are at the end. Not the case. And we decrement. Now we go from 7 to 6. Okay, and we jump. So we're doing this 7 times. I mean, you can see them appear here, right? But it sucks that it's like 11 wide, because you can't easily see that. I mean, I should like knob out or zero out these values. That would be more clear, I guess. But yeah, now we are pointing to CO2C. That's this one. Is the next one we're going to do. And that's also going to get an 8 in it. Yep. And we are at 5, 4, 3, 2, 1. Okay, now we have to check. Okay, so we're in the last iteration, I guess, or maybe one more. So yeah, we're sub. Okay, that's the level width. Yeah, that's now we go from 1 to 0, and now we do not take the jump anymore. Yeah, so if sub counter is not 0, so this is now false, right? So we're not doing this anymore. And now we increment HL again, meaning we're going to point to the next byte here, which is like D600, right? That's correct. Increment HL. Yeah, so we're pointing to D600, and now we are. Yeah, that's what we did here. No, in the DJ and Z is what we're doing here. Now we are repeating again. Okay. And we're doing this for every byte. So this is the little algorithm to load the level into the sprite table. That means that actually the data, like we have to make sense of this, right? And that's not really clear yet. So I don't know exactly how the sprite pattern table is defined. Like we can look at this. I mean, so what I was seeing is that there are 121 bytes here available. That's 11 by 11, right? So 11 times 11 is 121. So you would assume that the first sprite means like actually top left here, and so onwards, like left to right, top to bottom. But what's weird is like we're placing these 8s every 11 bytes, so it doesn't super make sense. Okay, but let's do the next one, because this one now, so OF had all 4 bottom bits set. We're looking at the bottom 3, so that's 7 plus 1 is 8. So the value we were inserting was 8 all the time. Now with OA, so 10 is 2 plus 8. So we have for the bottom 3 bits, we have only 2 left. So we're going to do 3 insertions of 2, right? Because we do, or 3 insertions of 3 perhaps. So let's see. Yeah, we're loading the next byte, which is OA in the accumulator. We're doing these routines now. That becomes, so 10 and 7 is 2. Yep, that becomes 2. We're loading that in our little counter here. That's this line. And we are processing with, yeah, so we're doing this now. We're pointing to D60. Wait, no, we're pointing to CO. Wait, let me see. I do still have to do an increment of C. Oh, that's a +1, I forgot. Wait. Oh yeah, wait. Where did I do this increment? Oh, no, that's this one. That's this one. Okay, I was confused. No. Oh, yeah, no. It's the other way around. Okay, we're still in the first thing. No. Never mind. Yeah, we were doing these still. But yeah, so this one has been copied into C because 2 became 3, yes. And that's our +11. Oh, no, we're actually here. So we did insert though, did we not? Yeah, we did it here. So, and that was 8. Oh, that's the top one. Okay, we are in OA. OA means, so 10 is 2 and 8. Okay, that's 8 again, right? Because OA has the 2-bit set and the 8-bit set, meaning the top 5 bits are 8. If we mask out the 3 bottom bits, right? Yeah, that is 8. So 8 is the value again that we are inserting. Does that make sense though? I think I'm confused here. This is not going to be correct. This is to be var2, I think. Yes. Wait. So first we inserted 88 and then we did 8, right? So it does change it then. Wait, let me see. Okay, we're not at the end of the, well, we might be though. We're at 2, so I guess we're around here somewhere, but we're not at the end yet. Yeah, so now we are here. No, we are here, I guess. No, wait. I mean, we're doing this 3 times, right? I mean, that, yeah, so we did this check. It's not 0. We're doing this 3 times because of the bottom 2 here. And we are writing this into CO60 and we're writing 8 again. Yeah, but this is wrong, I think. Because I think it's the bottom thing here, the var2. I think var1, the 3 bottom bits are just a counter, an amount of times we have to insert this value. But then why did it change from, well, wait, if we take the top 5 bits, I'm gonna get the calculator to be certain. The top 5 bits in 88 is 88, right? And okay, stupid fly. F7 was it? F8 and F8. Yeah, that's 88, which makes sense. Yeah, it's 1001. Okay, sure. So what I don't understand or forgot now is how this 88 got changed to 8. where does that happen? Because what we're inserting now is 8, and we did have 2 here, so 3 actually, so we have 3 iterations, but it's still 8 we're inserting, and that doesn't make sense, does it? Wait, does it? No, because var 1 here is 3. Was that the case? Yeah, it was. It was. Yes, it was. Absolutely, because otherwise we couldn't have 2 in C. Yes. We have to have our counter, but what we're inserting is var 2. And yet somehow var 2 got changed, and I'm skipping over that somewhere. So yeah, we are loading, taking the bottom 3, taking the top 5, right? Which we are loading into DE, which is our sprite table. Okay, we're taking 11, adding that, so we're incrementing our pointer into this array. We're checking whether we're horizontally fine, and we're decrementing C. In the first case, that was 0, right? 88 has no repetition. Oh, wait. Yeah, we had no repetition. Yeah, we're checking. Okay, that's fine. We're checking. We're not at the end. We're decrementing C, which was then 0 for the first byte. And then, which we're not doing this. We're moving to the next byte, and we're looping again, A517. We're loading the next byte, taking the top 3, taking the bottom 3, the top 5. And the top 5 is 8. Okay, the 8 is not coming from this byte, it's coming from this byte, right? Because that's F, which means the 4 bottom bits are set. If you drop the 3 bottom bits, that becomes 8, right? Same here, we have 10, which is 2 and 8. Drop the 3 bottom bits, that's 8. So the value we are inserting is the top 5 bits. Yes. And then we have a repetition. That's all that is. So this is wrong. Because we have to insert the var2 in the table, right? So that still works because we assign subcounter to var1 here. Yeah, this has to be this. Yep. So we are doing this subcounter amount of times, which is the bottom 3 plus 1. And we are inserting var2. We're always inserting var2. I mean, I can just leave this out because it's always var2. Yeah. So this is actually this. Right. Yes. I think that's correct. Okay, now what I want to do now is see what happens when we encounter the end of the line here, like the 11th or the 12th block, I guess. And what I'm assuming is that instead of keep adding stuff here plus 11, we perhaps revert to this byte here. So we started at position 0, adding 11, 11, 11, 11, 11. From position 0, I think we return now to position 1 and do the same thing, adding 11, 11, 11, 11, etc. That would fill up this entire array and converting from Yeah, I think this converts from a routine where we're going top down first to left to right. Because if these guys are left to right, what we've done is we've added the first column, right? Because there's 11 positions in between all the time. 1 second. Yeah. I don't know why they are stored that way. I mean, it would have been easier to just store them left to right, I guess. But I mean, I'm sure they had a reason though. Let's see. So yeah, now we have 07. That's 1, 2, and 3. Also, the value is 0, and it's going to be inserted 8 times. Okay, but let's see what happens now when this this jump, this one here, when this one jumps. Because I think we are close. What's level loading? Okay, we're at 1. We're decrementing now, so now it's going to happen. Yes. So A548, that's over here. Okay, we're doing something here. Okay, let's jump there. Oh, A548. Okay, that's fine. I jumped over one, but that's fine. We're loading hex 78. Interesting number. That's 120. That is 121 minus 1, 121 being 11 times 11. So that is a 0-based map length, right? Like the amount of blocks. Okay. So we're loading that into BC. I mean, that's actually this function here now. So temp is 120. Exchanging DA NHL, that's fine. We're checking whether, okay, whether A is 0. I mean, that's reliant on data, then that's unfortunate, but sure. So that's not 0. SBC was that again? Which one is it? HLBC. That's this one. Subtract BC and the carry flag from HL. Okay, that's why we checked the accumulator, I guess. So we're subtracting BC from HL. HL. Okay, yeah. Yeah, that's exactly what I was thinking. Yes. So our pointer ended up at the end, right? So we started at 0. We've done this 11 times. So we are pointing at CO79. Here, this one. And I'm assuming that's the end. So if we calculate, it's going to be around 121 bytes, I'm assuming. And also we subtract 121, so we go to the index 1, right? We're not subtracting 121 because then we would be overwriting exactly what we have done. We have to go 120 positions back, so we're at the next iteration to end up here. So if we see, we are at CO79. And the start position is C00, right? So of course that's 79, and that is 121. So yes, we are now pointing to CO79, which is the last bit, the last byte in the 121 positions, and that makes sense because we started from position 0. Increment 11 or like jump 11 bytes 11 times and you end up there. Yeah. And now we're simply going to subtract 120 bytes, so we end up to position 1. Makes perfect sense. Right, so yeah, C001 is HL now, and that's, yeah, okay, good. Okay, exchange DE and ASL. Okay, so now we are back as we were, popping, pushing AF. Okay, we're resetting 11 into our block counter. Right. We're saving that, and we are, I don't know why this, oh no, that's a non-conditional jump, right? A534 is back to where we started. 34, that's here. Oh yeah, no, because we're in the middle of processing this byte, right? So we're still like, this still has to happen, right? This check. So it's just, we're just in this routine, and what this does is this: I minus equals 120. Yeah. So we're like jumping back in our thing here. Oops. Yeah. That's all. And then of course, wait, what else did we reset? The horizontal block counter is reset to 11, which is what we're doing here, right? Like in initialization. Yeah, that's what we're doing in this little routine. And we continue. I don't think there's an unknown now anymore. Okay. Yeah, because we're just continuing now and doing these jumps. I now want to see when we take the last jump, which is this one, A517. That means we've processed all the bytes. So if we end up here, then we've finished processing, which I'm going to jump to now. Right, so this is now the level. And it doesn't look like the level, or it might. I mean, let me take a screenshot of that, because it might though. Yeah, it actually might. Well, no, it's ending here, I guess, right? So let's see. Yeah. Because if we look, 88 is at the top left, right? That is Lolo. This is Lolo. These are, I'm assuming, walls. There is a hard framer somewhere. Maybe this one. There should be 3. No, these are perhaps the snakies, because there are 3 snakies. There are a couple hard framers, yeah. Not sure. We're loading so D623. What is that pointing to? D623. Okay, that's the next level. We are loading that into DD4D. Okay. What is DD4D? That is the pointer to the next level, it seems like. Yeah, because we're dealing with remember the how the levels are stored in the ROM. We have a pointer table of like 20 pointers or more, and each pointer points to 5 levels. Of course, we need to know, seeing as the levels are stored in a variable length encoding, we don't know where to jump based on the starting pointer of the first 5 levels, or the first of 5 levels. We need to know, if we complete a level, where to load our next data from. So yeah, this is next level pointer, so that's DD4D. I mean, I'm gonna let it do it, so we can see what happens. Where did it go? Oh, just okay. This is linked. I'm going to let this execute. Right, so that is now, I mean, it didn't change, right? It was already D623, D623 being this pointer here. Yeah. So DD4D. We have nothing, well, yeah, that is, it was empty, right? There was nothing known here. So let's see, that's quite low down. Okay, I didn't sort these. D9, okay, let's put it here. I mean, it's a 16-bit pointer, of course, but so this is a pointer to next level data. Okay. What are we doing? Oh, is it confused about the code at the bottom? Oh, no, the window is broken again. Oh, crap. This keeps happening. It's annoying. See, this window is completely blocked. I can't do anything without... Oh, yeah, I can reset it, I think, by... where is it? Symbols. By reopening it. Okay, that's reset. Now, of course, I lost my memory thing. Yeah, okay. So now they are pointed to next level data. Okay, that's good. So we're setting that. But I'm thinking we're doing something still with this, though. I don't think it's finished yet. We might post-process these, perhaps. I mean, I can run and see where it ends up, what this ends up looking like. Let's do that. Yes, absolutely, it did. That's why I took a screenshot. Because this is what gets loaded from this data, right? There is no extra information in this data. This is it. Like, we have to be able to recreate a level from this level data. That's it. Because that's what gets written to disk and stuff. So yeah, there's nothing else. But it is post-processed, I think, or like used for something else, though. I'm not sure about that. Because this is a temporary thing. This isn't actually the sprite pattern table, I think. Because now we can look at it, right? Yeah, so what was 88 in decimal? No, I want that calculator. $136. Is that a sprite? Yeah, but the wrong one. It's Lola walking left, so that's definitely not a sprite index. 8 is 8, of course, and that is the eyes of a skull. Or Alma or something. Not sure what that is. So these guys are not sprite table indexes. Are they tiles? Well, no, they couldn't be tiles, though, unless it's the top left one. That wouldn't make sense, though. Yeah, pattern 8 is the exit door, and there's like a crap load of them. I mean, they might be like numbers representing entities, which they probably do, though. Like, but why do I not find a corresponding number, though? What I want to do is, can I select and copy this stuff? Is that, well, it's already gone, of course. I can't multi-select here, that sucks. I want to see this data in a different way, but also it starts at C000, so I can mess with the length here. Okay, let's do that. I'm going to not put a breakpoint here or a watch point. I'm going to, well, no, this one was good. Okay, let's stop this level and reset. And I'm going to make the width 11 here and see if we can see something. No control, stop. So we reset the level and we are loaded. Yes, we have our thing here again. And now, because it starts at C000, I can use the width to show 11. Can I? Yes. Well, no, it starts in the middle, but it looks like the level though. Like, that sucks. I mean, I need this selected so I can show this in as the level is, right? But I mean, if that isn't the level, then I mean, sure it is. Like, yeah. So 88 does represent Lolo though. Okay, I want to write something in C to see if we can do our routines. Try to see if we can get a load and save routine in C, that we can experiment with these values. I'm thinking these are just like IDs for specific blocks and mobs and stuff. I mean, they do get post-processed, but... And this is not necessarily the sprite pattern table, though. This can be... I mean, I've seen this being copied into the VRAM into the sprite pattern table, but it might still be like a little working area that's not like... It doesn't have to be the sprite pattern table, and it definitely isn't, right? Okay, let's see if we can do some code here. Where are we? Where do I want to be? I guess here is fine. Well, no, let's go elsewhere. I'm not going to make a makefile and stuff or a CMake lists. I'm just going to compile that by hand. I mean, let's output something. Oh, we do have to, what's that again? Oh, is it C++ that I have to use? Yes. Okay. I'm going to put this in a script. Okay. Okay. So let's copy our data, which we have in the save file. Yeah, that's this. So we start from, we had 4 zeros, right? So can I multi-select here? Of course I can't. Why can I not do a multi? Oh, yeah, yes, I can. Okay. Can I copy this? Of course I can't. Why can't I copy these bytes though? Oh no, wait, I can do this in with hexdump. Where is this located? Let me copy everything. Can I do this? I have to put OX in front of everything, but that doesn't matter. We have 3 power-ups and the position of Lolo, so these go away. And yeah, that's the first line, that's fine. And it stops at the next 3 zeros, that's these guys, right? That's the end. So A8 is the last one. That is correct. So these are our bytes. No, and yes, without the space. That'll fix itself. We need commas and OX without a space. That's fine. Okay, and commas. Does this format? We forgot a comma here. Why are you complaining? Is that not too many initializer values? Is that not? Oops. Okay. That should give us our data, right? So let's see. Well, the first 3 are power-ups. We're going to skip these for a moment, and this is Lolo's index and the Exitor index. Okay, and then we have our level data. The first 5 we don't really have to care about. That is just irrelevant information to figure out the level data, right? So we start at A5. No, we do not. That's the length. Okay, that's the length, which I'm going to comment out because we're going to give that as a parameter, right? So we have a function. And then we need a pointer to actually this should be a give it a T. Cannot do that. Oh, I need these things. Where are the C standard ints? Are they defined in there? Yes, they are. Did I call that? I know, right? That's length. I mean, block index is smaller than length. So we're looping all the blocks in the level. We have a horizontal counter. That's regardless of the block index, right? Yeah. We have a horizontal block counter is 11. I is going to be the index into the sprite pattern table. Okay, so we have a working memory thing. I mean, I guess it's a result thing, right? So we have uint a t array of 121 bytes, right? And then we have our result index, which is this one, and we have a sub counter. Okay, that's fine. I mean, I'm gonna follow the assembly anyway, right? So it doesn't really matter to put that in a nice thing. Was it 0 or 11? Yeah, 0. Okay, so then we load this. And that would be why are you complaining? Integral or unscoped in untype. What? Oh, no. Data, we have to index. It's block. It's block. It's not data. It's block. Right. And then we put sub counter as for 1. And we have our process function. Okay. Okay, I did mixed my things here. Can I not put this in a better way here? Okay, then don't format it. Okay. We get a parameter being, well, no, we don't. We just need to have access, I guess. But that's fine. We'll pass this pointer. That's line 8. We need to put this in result, so we need that, and then we're going to call process data with the result at least, and we have to pass sub counter 2 and horizontal counter 2. So horizontal counter was a global. No, it wasn't. Okay, so we need to call this one, and well, let's start with this one. Okay, I mean that's a bit long. Yeah, this one too. Okay. We need, okay, let me first copy this. So this becomes result of result index, right? We have result index. We have to pass for 2. Okay, we have to pass the variables as well. This needs to be a reference. For 1 and for 2. Okay. And then the horizontal block counter becomes that, and we have sub counter as well. Okay. Okay. I is the block index, right? Yeah, result index. What's this? First level was not declared, of course. That's below here, so I need to declare these. Okay, I'm missing something here. Okay, of course. Process data wasn't declared. That makes sense. Stack smashing, that's good. Okay. Let's see. So we're putting this. Okay, so let's log this one. Okay, that sucks. So I need to do this because I'm not gonna struggle with the formatting with the streaming library. I hope it's not complaining about my version of. I mean, yes, it does. Why are you not? Format is not a matter of standard. That's because I have the wrong thing, the wrong version of C++. G++ CLI specify version of C++. I'm usually, I mean, I'm working with CMake, of course. So oops. Come on. Okay. Position 122. Okay, so we are indeed writing beyond the we are writing beyond the size of the array. That's why we're crashing. You stop complaining. 122. So why do we want 22? Okay, so let's give it a bit more though. Oh no. It should be 121 though. Oh no, there's way more apparently. So I'm guessing I make a mistake, but let's see how far we are. Okay, 140 for some reason. That's a bit weird though. Why would we go that far? But yeah, you never know. Now let's dump this. Okay. Now let's dump the data, right? And we have a UNT pointer. I'm just going to do the first 120, right? I mean, I can do more later, but so we are going to loop no, this is y first, 0, y smaller than 11. And then we'll do x. And then we will output data, meaning y times 11 plus x. That's the index. That's going to be, I mean, I'm going to put a tab here because the values are going to be varying in width. So we'll see how that looks. I mean, that should work, right? Dump level is, let's put that at the top too, so we can call it. And then after this one, we do dump level. No, we have to do that earlier, or later, I mean, because we don't have access to that variable. Otherwise, dump level result. Let's see what this does. Okay, so these values don't make sense for sure. I don't know, I need to insert a new line after this. Yeah, that does look nothing like the level we're looking for. So it should look like this, and that's not what it is. I mean, it is hex, so maybe I can do what is this? Is like this. Is that hex? Yes, it is. So 88 is fine. 8 is fine. I mean, can I do width too? Is it like this? Yes. So 88, 8, and then A8. So we did make a mistake in the interpretation of the algorithm, though. Can I do ANSI colors here? Because that would be handy if I can do ANSI color. I just need to know the codes. Okay, so it's this guy, and then let's take this. We just have to output that, right? I think it's simply putting this one, and then what's the reset? This one, okay. No, I just have to output these. I think so. No. So auto value equals this. And then if value equals 0, we do something, and else we do this. I mean, I guess I can do that separately. Okay, if it's 0, we do a different color. I mean, I don't know if that's correct though. So let's try it out. We have to put a reset here at the end. I mean, that's not super necessary, but I mean, I guess I could have. No. I guess I'll put it here or here at the very end. Yeah, I want different colors for the zeros. That's why. Regular colors. Do we have low intensity? Okay, high intensity then. Bold high intensity red, green, blue. If it's not 0 and otherwise it's a simple white. I'm not sure if this is going to work though, but let's see. It does. Okay. Yeah, so our 88 and 8, the first 8 works, but then not much after that. We can also just do this now, so they're closer together. I mean, actually 1. So 88, 08. I mean, this is come from the next iteration though, so we're looking at 88 and then 11. Oh yeah, it's going to be this guys, right? So this is the first column first, because we're always incrementing or adding 11 here, right? So this F0 is wrong for sure. Right, so we're going, this is 8, 9, 10, 11, so it stops here. And then this was the first one. Okay, so this should be 8. Okay, let's see. What do we have here? Let's output this. So our input is in hex. Input is block, and the output for var1 is this. Actually, well, yeah, no, I can do that in hex, that's fine. And a variable 2 as well. Oops, I copied a K or moved that around incorrectly. Okay, let's see. So our input is 88 and our var1 is indeed 1, that's correct, and var2 is 88. So we are not, so subcounter is 1, that's fine, and subcounter, oh, I think this has to be below or outside of the loop. Yeah, I think this is what happens. Because we're not supposed to take the loop. Yeah, let's look at the assembly again here. Where are we? So we're ending with 7 and ending with F8. Yeah, we're at the top, right? So yeah, this is it. We're ending with 7, ending with F8. No, this is a different loop. And then we were at the end. Okay. Yeah, ending with 7, ending with F8. This is a loop. And we're looking for the sub counter being C, I think, being decremented. That's this one here. And then we decide to jump right. So we do have to do that outside of our check. Yeah. So that's at least the bug that's fixed, but it's still not correct though. So we start with 88, and the next one should be 8 here as well. So we input 88, and then let's see. Every time we write, we should put something outside or put something on the stream as well. Hi Danny, I do not speak Spanish. No, sorry. I'm from Belgium in Europe, so Spanish is not taught here, I'm afraid. So we are writing at position value this, and the position doesn't have to be in hex. This I'm going to put in hex. So this is result index, and this is var2. Let's put a new line here and put a tab at the front. Okay, so yes, the first one is correct, right? Writing position 0, we're writing value 88. And then for OF, we're writing 08, that's also correct. At position 11, 12, okay, 11, 22, 33, yeah, that's correct, for sure. The shape without the background behind me. You mean in the camera here? Without having to understand English. I mean, it's green screen. You have to get it. I mean, I don't know how to explain it in not English though. It's a green screen. If you go to this link here, OBS green screen. If you search for this, you get tutorials as many as you want. I mean, I'm sure there's going to be tutorials in English as well, but yeah, there's lots of information about green screens online though. You just have to have good lighting and a decent camera and then a green screen, literally. Yes, I do. It's a green screen. So yeah, that should fix it. That should do it. So what ends up happening is that we're going, no problem. What ends up happening is that we're overwriting values, right? Because if you look at the end, we are indeed seeing a 0 here. So I'm assuming that we are overwriting position 11 again somewhere. Okay, so that was the first one. Yeah, that's the first one, and let's see the next one. Entire word only. Yeah, of course. So way down. Yeah, okay. And again, 22, 33, 44. So for some reason, how could it be looping twice? That would be... I mean, it's looping all the data though. That's weird. What input is that? Zeros. Wait, did I copy 2 levels? Oh, I might have copied 2 levels. Wait, does it look like a second level perhaps? Oh no, but yeah, did I copy 2 levels accidentally? Let's see. No, I did not though. I was looking for the zeros indicating. Wait. The first one, and then this one, the input is 0. No, this is not correct because I don't have that in my data here. There's no sequence of multiple zeros. So actually, okay, let's add the index in the thing. So the block index. Oops. Let's add this. Right, so block index 0, that makes sense, right? And then we will look for the next one here. Block index 37. But we don't have 37 bytes, so am I that wrong? Length is A5. Okay, A5. Oh, that's 165. What? That's not correct. Because it's not 165 bytes. How is that possible? This is like 30, 40 bytes, right? From 52 to 16. Yeah, and that's 42, and then that's 36, 37 bytes. So this is not. This is wrong. Okay, so let me first adjust that by counting the bytes here, 16 and 52. And just to be sure, of course, I don't make a mistake here. 52 minus 16, that's 36 bytes, right? So let's see if I can fix it that way. Yeah, and now we have the, oh no, it's one more, I think. Yeah, of course, it's yeah. So now we see our level here, right? This is literally our level. Although this looks like a mistake, though. Is that in the level? Let's see. There shouldn't be an opening, I think. Wait, let's continue here. Is that similar to what I have? So yeah, the zeros are the walls, but we're not counting these external walls though. So 88 is lower, and then 08 is space. Oh yeah, no. 0 is wall. So yeah, so 40. So we have 40 and A8. A8 is probably the hard framer with bullets in it. Yeah, A8. That's this one. Is this A8? That definitely has bullets in it, so there's this one, but then these two last ones don't, so that's 40. And 20 is a snaky, yeah, 20 is snaky, yeah. So we do have our level though, like we do parse it correctly now. We did figure out that this is not the length unless it's, yeah, that isn't correct. So we'll have to look at that number, but at least we can parse out the level now. Question is, like, I don't know. I mean, obviously 88 is low, right? Like we can figure out what every element is, but I haven't seen these numbers anywhere else though. I do wonder, so snaky is 20, right? That's 32 in decimal. I wonder if it's the same in the password screen. So 32 or 20 hex for snaky well, the snaky left facing front, right? So let's go to the password screen, because they might be the same there. No, I need to control. I'm going to turn these off. Okay, come back here, play, control, stop. So if you go to the password screen and we look at the entered password, yeah, that's D85A. Do I have another one open? Oh yeah, I can put this back on 16 though. So yeah, these guys here, it was this snaky. Yeah, that's 10. So, but it's OA, it's not 20 at all, so these indexes don't match either. That's quite weird. Like, why would it be so many different indexes or IDs for every thing here? I mean, at least we got the level though. Okay, let's look at the length here, because that's not length at all. So I'm gonna put a watch point here for a read, and I'm gonna start a level. Okay, we break here. Wait. Okay, we're higher up now, right? Okay, yeah, because we're. Oh, are we taking the bottom X bits, perhaps? Yeah, and the top bit. Oh, we're dropping the top bit. Yeah, that's what we did see this. So we have to, from A5 here, we have to drop the top bit. So if you look at A5, that is, no, an hexadecimal. Yeah, that's 10100101. So that's 165, but we want to drop the top bit, and then we end up with 37, which is what we have. So actually, data length is and then is OXA5, but then byte count is data length, and what's the number? 7F, so the bottom 7 bytes, bits of course, and then we have bool. Well, no, it's 8, I guess. U&AT unknown is data length and OX80, which is then the top bit, right? The top, all of them, I guess. No, it's just the top bit. Yeah, 128. That's the top bit. And then byte count is submitted here, right? And that would make it work as well. Yeah. Right. We should find a level where the top bit is set though. 1 second. So let's see. It's A5. Can we visually see that, whether the top bit is set? Well, A5 it has it set though. I guess where it's not set. So what do we do with that information here? Let's see. I have to activate thing again. Okay. Let's see. So we take the bottom 7 bits, loading that in B. That's 25. That's 37 hex, I guess. And we're loading what HL is pointing to in A. HL is still pointing to D5. Okay, sure. We're doing the same thing. And then we're pointing to the next one. We're adding again A5, our value there, with hex 80. We're taking the top bit. Oh, and we're jumping if it's 0, which it isn't, right? Because the bit is set to A55C over here. This one. Okay, so I do want to trigger that. And it's going to depend on which level we load. I'm not sure which level is going to trigger that, so I'm going to have to figure or find a couple, I guess. Disable the watch point. We have one breakpoint, the one we're interested in. Okay, so not this level. The watch points can go away, that's fine. Level 2. Does not have it set. I have to like go and process the exit, otherwise if I load the save state, then it doesn't do that. Okay, so level 3 does have that. So that's level 1, that's level 2. This is level 3, right? So we have lowest position, we have exitor index, and we have the length 19. That makes sense. That's quite low, so that doesn't have the top bit set, and it does not indeed. So now we see what happens here. So we have 19. Wait, so 19. Yeah, that's 19 bytes. Sure, 19 hex bytes, which is 25 bytes until the next one here. Yeah, so that's 16 and 7. That's 23, 4, 5. Yeah, that's 25. Yeah, these are 25 bytes until the next set of power-ups for the next level. But yeah, now this one is not set. And we are checking what HL is pointing to. That's D65E. Oh, that is the next. That's the first byte. Okay. We're looking at the first byte of the level. We are checking whether the... Well, no, this is the same thing, though. This is the same algorithm as with what we have. Where are we? Where are we originally? Yeah, and with 7 and F8. Yeah, that's the same thing. 7 and F8. Okay. Again with F8. So there's the bottom 3 bits and the top 5 bits being separated. And we are pointing to D65E in, to C000. Okay. That's the same routine. And we're jumping to A564. Okay, that's right here, right? So this is a different routine. Okay, so we're doing that a couple times. That's fine. Okay, we've done that. We're increasing HL and we're looping again. Yeah, that's a different routine for A55C. Yeah, it's this little routine to decode level 3. Why would that be different? Because it's way simpler, right? That would mean that we cannot decode level 3 with our current algorithm then, because it does something else. So if unknown is set, we do this, but else, well, no, I'm not going to do that yet because I want to see what happens if I process level 3 or round 3 with our current routine, right? Okay, I need to do the hex dump again. So round 3, so this is 1, this is 2, and then we have is this 3? It should be only 25 bytes. Yeah, this looks like it's short enough. So now we have oops, I shouldn't have done that yet. I need to remove this and this. So we have the 3 power-ups, low loss position. Okay, and then okay, no, let's do them all and let's comment them out. So this. Oops. And then we copy this like this here. Not sure that's gonna work. No, it does. Yeah, so 3 power-ups through 2 indexes and the length. We have commented those out though. Okay. And let's do round 3 then. I mean, I should put that in the. I mean, we should parse that from the array, of course. But yeah, we're just so that is 22. That's not good. Oh, we didn't compile correctly. Okay, I didn't put a semicolon, I guess. Oops. Yeah, that's not correct. That's interesting. So we have a different routine if that's if that is either 1 or 0, the top bit. That's very weird. So let's first see if we can actually parse this though. So let's remove that. And then let's, so data length is, okay, let's get a pointer first to round data. Round equals round 3. And then we can say round index well, let's give that a value or a define or something. Oops. And then we have data length, and then data is 6. All right, so now we can say the data length is data length. And then we have the byte count and the unknown. And then if unknown, that's just a Boolean, right? So if unknown, we do something else, we do something else. I mean, I'm going to call this, well, no, I'm going to call this level 1, I guess. What are you complaining about? Oh, yes, that one too. I mean, this will go away, but that's fine. And then parse level, well, it's not level 1, of course. I mean, it doesn't matter. I can call this parse level 2, that's fine. No, it's the other way around. Because if the bit is set, we have to do our original routine, and if it's not set, we have to do something else, right? And we have to pass around data as a parameter, and the address of that, of course. Okay, let's see. And then we're going to get a different function here, which is going to be simpler. And let's see if that still works for round 1, though. So let's compile this. Okay, yeah, parse level 2 needs to be added at the top. Okay. Are we here? Why are we here? Data length and OX80 equals OX. That should be fine. Oh, no, it should just be a bool. Okay, why are we... false? $32. Oh, right. Yeah, okay, so that's our original level. That's correct. Okay. And yeah, so this is fine too. We can turn this off for a moment here because our parsing is correct. Okay. Now, what do we do in this second routine here? So we jump here and we're loading HL into A, right? So we're getting the value, we're ending with 7 and we're increasing it. So that's the same thing. We're doing this. Okay, I'm gonna have to copy this. So we have a result, we need the block, we do it in a loop over all the blocks. That's our DJ and Z here, or Z at the bottom. So yeah, we're doing this. We're loading again, we're doing with F8, that's variable 2. Where's our variable 2? Oh, here. No, it's too low. Variable 2 we do as well, so we do FA, and we are writing that in oh, and we're just increasing DE. So DE is going to point to C000, our end thing, right? Our data here, our result. But we're just increasing the pointer. So we're not doing plus 11 like it's the 11 increment thing. Okay, so we are doing the write for 1, for 2. So we're doing this. And we are doing this for 1 times, I think, right? Because we put, yeah, we're putting the plus 1 into C that contains the plus 1, that's for 1. And we are doing that or yeah, we're decrementing, so we are doing that. If it's not 0, we're doing that a couple times, okay? And then we go to the next one. So our process data 2, I mean this is process data 1. And then we have a process data 2, because we have to recursively call this one too though. We need the result and the index. We do not have a horizontal block counter at all, because we're doing sequential stuff. We don't have a sub counter. We do have for 1 and 2 though. So this goes here, because we are jumping back to A564, which is here. Yeah, that's the first thing we do in this little routine. So we do this. We have result index. Well, we don't need the result. Well, no, we increment. Yeah, we increment. So this is result index plus plus. For 1 and for 2, I don't think we need both, but let's make sure. So we're ending with 07, we're ending with F8, okay? We're loading the F8, so var2 in the thing, that's this one. We're increasing DE, that's this one. We're decrementing C. Oh, we're looping this. C times meaning for 1 times, okay. Okay, so we don't need this one. We need to have a loop here. We're doing this for 1 times, I think. Right? Yeah, so we are, it's for, yeah, plus 1, okay. And then, again, loading the 5 top bits into the value. And then we're decrementing C, which was this one. Yeah. So this should this work already? Or would it? We're still doing round 1 here. We have to switch to round 3. No. Oh no, we're not printing. We're not dumping. Are we? We are not, right? Yeah, we need to dump level. And then we will see what it ends up with. That does not look correct. So there's lots of space though. I mean, yeah, no. I have 40, which is the, so it should look like 4 almas. Let me load level let me load the level, wait, because here we are, right? Maybe I'm looking at the wrong level even. I'm gonna disable you. Well, no, let's remove this one and this one and disable this one, and let's continue. Yeah, so it's the 4 goals and the thing and the part framer and the block. So the 8s are spaces, that's fine. And then we have 2 40s here. It goes wrong here though. So the 40s being the goals, I'm assuming, but then it goes off the rails here. Okay, so let's look again at the algorithm here. Oh wait, maybe there's something else afterwards, because we're jumping to 55C, that's the top here, and then pointer to next label. No, we're saving the pointer to next label, and then it returns. Okay, no, that's literally, this is this routine. So I'm doing something wrong though. We're loading the value. We're taking the bottom 3 bits, we're loading that into C, which we increment. That's this line. Okay. And then we take the bottom 5 bits, that's the value we're going to insert. Okay, that's no big deal. We increment the pointer, that is this guy here. And we're removing one from our var1 here. I mean, we're doing it the other way around here. We're counting from 0 upwards, whereas here we're counting from var1 downwards. But that shouldn't make a difference, right? I mean, I guess we can do that though. So I is for 1, and then I not equals 0, and then negative direction. Like these zeros, these are walls, so that's definitely not correct. I do want to see how it looks like in the memory here though, like we did for the first one. So let's put a break on this one. That would be the last one, right? The last pointer or the last data byte in the 3rd level. So let's put a read watch point on this one and reload the level. Then we can compare what my algorithm does and what theirs does. Okay, I have to put in the watch point again, because of course it removes the watch points. This one, was it? Yes. A read watch point, and I'm exiting this level. Okay, we did break there, and now we will see what C000 looks like. Oops. Yeah, that looks different though. So we have our 8s. The 8s are correct, but then we have 48 as the goal, the front-facing goal. I mean, the 58 doesn't make sense either though, because we do have some 40s. We do not have the zeros. I mean, I'm guessing I'm gonna have to run through, I guess, but yeah. And let me check again. So we load the value, take the bottom bits, bottom 3, and that's a counter +1. Okay, that's the counter. We're taking the top 5 bits, and that's our value to load. 5, 6, 4. We keep loading and increasing the E and decrementing our counter. That's exactly what's happening. And then we go to the next byte. That's exactly what's happening though. I don't understand. Oh, no. No, stop. Of course, that's an infinite loop. What did I want to do? I wanted to check. So if it's not 0, wait, let's do it the other way around again. So I is small. This is what I wanted to try, like get an extra iteration in there. No. That's so it should be only this amount of times. It looks so different though. That's weird. So we have 16 eighths. Well, more than that, right? 16, pretty much 32, and then we have 48. 11, 22, like there's way more. But this doesn't make sense if you look at a level either though, like we have 48 and then 58. And I'm 40. Like you have 4 front-facing goals, so they should be the same number though. I guess we'll have to figure that out next time, because I can't think anymore. Alright, thanks for watching. Until next time.